We're going to first start off by reading the information above. It says, use the data to create a line plot and answer questions about it. The students in Mr. Cushing's science class measured the heights of their bean plants to the nearest half inch after 1 week's growth. I'm stopping at the end of my period and I'm thinking to myself, there's a classroom of students here who have planted bean plants, and they're studying them, they're observing them, they're measuring them and how much they've grown to the nearest half inch after just 1 week. And then they give us the data. The heights measured were. Looking closely at this data, I'm going to recognize that this 10 is one person's bean plant. He measured his bean plant and it measures up to 10 centimeters after 1 week. 10 inches after 1 week. Another student's is 9.5 inches. Another student's is 11.5, 10.5, 10.5, 9.5, 11, 11.5, and so on. So these are all different students' bean plants and what they've measured after a week of growth. Part A tells you to make a line plot displaying the data, being sure to include a title and a label. So now that we understand what we're looking at as far as numbers, a good title might be something to do with bean plants and their growth. Maybe we just simply want to call it bean plant growth. Bean plant, I'm gonna make sure it's capital letters for our title, growth. Okay. Then we're going to come down and we're going to label. Actually, I think it would be smarter to look at our scale first. So remember, when we decide what numbers are going to go here on our number line, we're going to scale them looking for the minimum and the maximum, or the smallest and largest number we see within our data. So looking here, I see a 9.5. So far, that's the smallest. And I see 9.5 is the smallest. So I'm not going to really worry about anything else right now, but I know I'm going to be going by half inches. We talked about writing sideways so that you can fit this data. 9.5. 10, because I'm going to go by half inches. 10.5. 11. 11.5. It doesn't really matter if I go back and I look at my maximum while I'm creating my scale, as long as I started with my minimum and I've counted by half inches here. I should hopefully be able to have my max on here. So now I'm going to go back up and check and see if the biggest growth of a bean plant is 11.5 inches or less. If there's anything greater than that, I'm going to have to reconfigure this. There's an 11.5. Looks like that's the largest one, so we're set. Now we can add this other label, and this label is going to be representing what are these numbers that we just listed up here. Okay, well, we know that this is a measurement to the nearest half inch. Remember, we talked how important it is to make sure that you actually add this unit in there. This is your measurement, and then in parentheses we're going to say the nearest half inch. And I might run off my page here. It's okay, I'll fix it in a second. Okay, so there we go with our measurement label. And I'm telling you what, it's really, really important that you have this actual measurement here in your label. If you don't have this on your test, you're going to lose points. As of right now, you would have gotten 1 point for your title, 1 point for your proper scale, and 1 point for your label. That's 3 points already on your test. Now we have to plot our data, and you're going to be getting points for that as well. Get off of there, sorry about that. Okay, so let's start by plotting our data, and I've told you before that I think the best strategy is to go down the list. Don't look for all the same numbers, but go down the list one at a time, plot it, and then cross it out. So the first thing I see is a 10. I'm going to plot it, and I'm going to cross it. Then I see a 9.5. Plot it, 11.5. Plot, cross, 10.5. Another 10.5, so I'm going to go right above it. 9.5. 11. 11.5. Another 11. 10.5. 10.5. 11 and a half, 10 and a half. Now I've plotted all my data and I've focused to make sure that I didn't miss any of them. I can look at this data and I can analyze it. I would get a correct point for being able to plot my data. And now it says, what is the height of the tallest plant? This could also height to the nearest half inch. That would also be an acceptable label. All right, the tallest plant I see measures in at 11 and a half inches. So that's my answer there. I'm getting the plant height. This is my plant height. What plant height is the shortest plant? Okay, my shortest measurement would be 9 and a half. Letter D, what is the difference in length between the tallest and shortest plant? When I see the word difference, that tells me to subtract, and it says write a number model to show your solution. So I'm going to simply take 11 and a half minus 9 and a half equals maybe I for inches. This is simple because I can subtract my whole numbers, and I know 1 minus 1 is nothing, so it's actually going to eliminate this fraction altogether because it would be 0 over 2, and we're not going to put that there. So 11 over 9 is 2 whole inches in difference. So some kids' plants were 2 inches taller than their peer plant growth. This is worth 1, 2, 3, 4, 5, 6, 7, 8 points. Do not mess this up or it could really mess up your grade. Take time to rewatch this part of the section if you want me to go over it with you again. Let's look at number 11. It says for us to draw pictures of these turns using an arc to show the direction of each one. The vertex of the angle and one side have already been drawn for you. And so we've been given a ray here and a vertex. There's our point. And now we have to do a 3/4 turn clockwise. We got to think the direction of a clock goes like this, and we're going 3/4. So here is where we start. We're going to say 1/4 turn, 2/4 turn, 3/4 turn, the direction of a clock. So we're going to end up out here. And we're also going to show that our arc goes the direction clockwise. If you leave off the arc, you're going to lose points. Now we're going to do a 1/4 turn counterclockwise. So if we start here, counterclockwise goes this direction, and we're going 1/4 turn. That's going to just simply take us up to here. So there's our ray, and we're going right here. Pretty simple. Number 12 says to estimate the size of the angle at the right and then circle the best answer. You have 2 steps to this part, number 12. So we're looking at this angle. Arc goes counterclockwise. I'm noticing it starts here, it ends over here. I know I'm using my knowledge of a right angle. This is where a right angle would be, so it's obviously past that, which means it's going to be greater than 90 degrees. This would be acute, this would be right, this would be obtuse. So I'm going to circle that, and then I'm going to write obtuse on the line, showing that I understand degrees and the naming. Same thing down for letter B. Estimate the size of the angle at the right and circle the best answer. This time I see that we start here and we go this direction of the arc. No, using my knowledge of a right angle again, I know that this would be 90 degrees. However, my angle is smaller than 90 degrees. So it's going to be right here, and we know that that means the angle is acute. Pretty simple there, but again, don't forget to do both parts. If you only do one part, you're going to lose points.